Alright, so we just got done with congruent figures. Now we're going to look at similar figures. First of all, this sign right here means similar. If you notice, that's my congruent sign. Similar is just like that, just without your equal sign. So you can kind of use that as they're the same shape, but not the same size. They're not equal. But we'll get to that in a second. So my definition of similar figures, two things happen. Alright, the first thing that happens is that all my angles are congruent and all my sides are proportional. Angles being congruent, that's super easy. What we've been doing all along, just angles are exactly the same. Sides are proportional. What that means is that they have the same ratio. When you simplify the ratios, they're going to be equal. If the ratios are equal, then I have proportional sides. And when we have similar figures, we have the same shape, but they are different sizes. So what I think of is like what we see in the movies all the time, when you have a house and then it's those like obnoxious people that have the mailbox is exactly like the house. Those are similar figures. The houses are exactly the same except one is bigger than the other. Alright, so here's our first example. Okay, so make sure you take a second, make sure you got this copied down. But here we're looking at ABCD and FEGH, and I first want to figure out if they are similar. So first of all, the first things that happen when we have similar figures is that we have congruent angles. So let's look at my corresponding angles that are going to be congruent. So here I have that angle A is congruent to angle E because they're both right angles, so that's my right angle congruence theorem. I also know that angle B is congruent to angle F because that's given. They both have those three arcs. I also know that angle C is congruent to angle G. Again, two arcs, so I know that my angles are the same. They're congruent, and that's given to me. And then my fourth pair of corresponding angles are D and H. They both have one arc, so I know they're congruent. So we got my corresponding angles are congruent. We got that checked off. The next thing I need are my corresponding sides to be proportional. So remember, proportional, all that means is that my ratios are exactly the same. So I'm going to take my two sides that look the same and set them up as a ratio. So I'm going to use AB and EF. And remember, all a ratio is a fraction that compares two sides. So here I got AB, and here I got EF. Those are corresponding, so I want them to be proportional, so I want to figure out what the ratio is. So I know AB is 9, and I know EF is 12. I also see that 3 goes into both 9 and 12, and that'll leave me with 3/4. We can always plug this into our calculator, but we want to make sure that we simplify as much as possible. Alright, my next pair of corresponding sides are going to be BC and, so BC and FG. I'll just, let's see. Okay, so we got We got B, C, and F, G. And I know that those are going to end up equaling. So BC is 15, FG is 20. I see that 5 goes into both 15 and 20, so that's going to leave me with 3/4. So far I'm on the right track because my ratios are the same right now. I just want to make sure that it happens for all my corresponding sides. So next I'm going to look at CD and GH. If you notice, I have A, B, B, C. I have this whole segment on top. I'm going to keep it that way so I stay consistent. Whichever figure you start with, make sure you keep staying with that on top. So here we got CD and GH. I know CD is 6 and I know GH is 8. 2 goes into both of those. 2 goes into 6 3 times and 2 goes into 8 4 times. So far I'm still on the right track. My last sides are going to be AD and EH. I know I'm starting with AD up top because I've been starting with this figure up top the entire time. So when I look at those, I know we're going to end up having 12/16. So I'm left with 3/4 the entire time. So here, when I simplify, all of my ratios are 3/4. So I know my corresponding sides are proportional. This is where we're going to go and write our proportionality statement. All that is saying that all my ratios are equal. So that's all I'm going to say right now. AB over EF is equal to BC over FG, which equals CD over GH. And last but not least, I know that equals AD over GH. Now, since I have my corresponding angles congruent and my corresponding sides are proportional, I know that my figures are similar. So I'm going to end up saying ABCD is similar to EFGH. Now, if you notice, this is just like when we talk about congruence. I want my corresponding parts in the same spot. So I know that A and E are congruent. And I know that AB and EF are proportional. You can look at that the entire, for all of these, it works out. All my congruent angles are in the same spot and all my proportional sides are in the same spot. Again, this right here is my proportionality statement. And this right here is my similarity statement. We have something that's called a scale factor, and all your scale factor is going to be that 3/4. It's your ratios simplified. That just ends up being your scale factor, and that's what that SF stands for. Alright, so here's example 2. This is going to be similar, except I already know my triangles are, I guess similar is a bad, oh well. But I already know my triangles are similar, and we're going to use that in order to find x. Oh, actually I lied. That's my next example. Alright, all a scale factor is the common ratio between all your sides. So that's your common ratio. So all you do is find your corresponding sides. Here, AB and DE are corresponding. So I'm going to take 3/6. And I know that simplifies to 1/2. I want to end up checking that for all my sides. So if you notice, 4/8 ends up being 1/2. And 5/10 ends up being 1/2. Think back to when we did our proportions. Whatever comes first is going to go in your numerator. So here, I know that 3 is part of ABC. ABC comes first, so I know I'm going to put 3 up top and simplify. You'd want to go in and make sure that all your sides have the same ratio, and they do. So, in a second, I'm going to ask you what your scale factor is. Make sure you got that down. Now here's my example where I'm going to use the fact that my triangles are similar in order to find x. Alright, so what you got to do is you got to take two sides that are both known. Here, well, you got to start with two sides that are known. and what you're looking for. So here, I know I'm looking for x. So I'm going to take DE and what is corresponding to. And I'm going to make a ratio. Then I'm going to take two things that are both known on the triangle. So here I know that, good color, here I know that BC and EF are corresponding and they both have known measures. If you notice, I also know AC and DF are corresponding, but I don't know anything about that side. So that's why I'm not going to use 15. However, I am going to use 6 and 9. So I got BC and EF. If you notice, we got corresponding sides are horizontal. AB and DE are corresponding and BC and EF are corresponding. And I also have that AB and BC are in my small triangle and DE and EF are my big triangle. So those are my relationships horizontally and vertically that we talked about yesterday when I set up a proportion. So now I'm going to plug in what I know. I know AB is 14, DE is X, and BC is 6, and EF is 9. So here I have a proportion. I can go ahead and cross multiply and solve, but I'm going to simplify first. I see that 3 goes into both 6 and 9, so I know 6 over 9 is going to simplify to 2/3. So here's my new ratio. And this is when I cross multiply. I know that 4 times 3 is going to be on one side. You got an equal sign, and we got 2 times x on the other. Then I simplify and solve for x. So 4 times 3 is 42. 2 times x is 2x. All we do now to get x by itself is divide by 2. So my final answer is 21. Super simple. That's all it is. So make sure you got this down. If you got any questions, please let me know.